This is the ROS Developers Podcast, episode 52.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez here from The Construct, and today I would like to dedicate the podcast to those students that aim to become a ROS developer. If you are studying ROS for your undergraduate course, for your PhD thesis, for your job at robotics companies, just would like to tell you that sometimes ROS can seem difficult and complex. But I can assure you that if you persevere, you will master the beast and become a developer for robots with ROS. So know that this episode is dedicated to you. And today it is my pleasure to introduce you Simon Steinmann. Simon is a student at University of British Columbia in Canada. There he works at his master thesis on robotics and machine learning. And since he needed to learn ROS for his thesis, Simon enrolled the Robot Ignite Academy to boost his learning. And that is how I met him actually, because he was learning at the academy that we have. Today, Simon is going to tell us more details about his ROS experiences and why he needed to learn ROS and many other things about his thesis and research on robotics. Welcome to the podcast, Simon.
Hey, Ricardo. Thanks for having me.
It's a pleasure. So, it's that you have been why we decided to talk to you is because you enrolled the academy. You also sent us a post about your interest in ROS that is going to appear later in our blog in a couple of weeks. But also you started to learn very, very fast with a lot of interest and also answering questions in the forum, for example, of the academy. And that's why I understood, wow, this guy is really interested on learning ROS, and I wanted to invite you here to the podcast.
Yeah, definitely.
Yes. So then the first thing that I would like you to explain to the listeners is what are you doing for your master thesis?
Okay, so I'm studying aerospace engineering, actually in Germany at the University of Stuttgart. I'm almost done with my master, so I only have to do the master thesis. And one of my professors is the head of 3 institutes of DLR, that's the German Aerospace Agency, a bit like NASA in the United States.
Uh-huh.
And through him, I got this cooperation between the UBC, University of British Columbia in Canada, and the goal is, one of the institutes of DLR, they deal with carbon fiber composite manufacturing.
Okay.
And so far, that is mostly done by hand, because dealing with fibers, it's fabric until you infiltrate it with resin and then basically bake it. So fabric can scratch, it can crinkle, and building components for aviation and for space, it has to be very precise, repeatable. The quality is very important. So DLR developed a new robot that is very complex, that is supposed to learn to grip fabric very precisely and place it very accurately and already deform it to the correct shape for the part. That is something that is too complex to program in a traditional manner, like move X, Y, then apply this pressure, then move there. Because there's so many variables that a human just can't do that. So the goal is to use machine learning, reinforcement learning, to simulate a task with a digital twin, so like a physically accurate representation of the robot and the fabric, and for the robot to learn the task virtually, and then after it has learned the task, to basically for the AI, the machine learning, to actually move the physical system, the robot. And so there is a student here, a doctorate at UBC, who basically develops the brain, you could say, of the whole system. And my goal is to make sure that the simulation and the brain and the real robot are able to communicate, so that the model and the environment provides all the right data for the machine learning, and that then later on the machine learning cannot just control the simulation, but the actual robot. But then there was the problem that the simulation of that complex robot, you need very complex simulations for the fabric. And the suction, it's very complex, and the simulation is not ready yet. So we decided to do the process of simulating and training the brain basically on a much simpler robot. And we chose
on a what? Sorry?
Kinova.
On a what?
On a much simpler robot.
Oh, much
Just
simpler.
A simple,
Yeah.
Yeah, a much simpler robot, like a 6 degrees of freedom gripper arm by a company called Kinova. They make lightweight assistant robots. And so we use that. The company already provides the simulation files for Gazebo. And that's where basically I very quickly came to decide to use ROS to control that robot. And then I had to find a way to talk to the AI, the machine learning with that.
Okay.
And, yeah.
Okay. Yeah. Well, that's a very complex setup. And then, if I have correctly understood, so you're going to use this Kinova as a simplification of the actual robot that you are planning to use, so as a first step towards a goal.
Yes.
And which one is this other robot, that more complex robot? Is it a commercial robot, or is it a robot created at your lab?
That is a prototype being developed at the institute, at the DLR, the German Aerospace Institute in Augsburg, that specializes on fiber composite manufacturing or lightweight manufacturing. And it's actually the gripper head that's the complex part, and it's probably attached to some other type of robot. But the goal is to create a method that is independent of the actual robot. As long as you have a simulation of the robot, you can connect it to the same machine learning and then control it later on. So basically, we want to build the methods as a whole package, basically. And then the only thing you have to put in is your own robot. And it learns it.
Okay, do you know about this method that is called domain randomization?
No.
Okay, it's a method for trying to achieve that, where you are. It's a method. I don't know how much it will adjust to your specific case. Okay, but basically, what it consists is that you train your robot in the simulation by including many small modifications into the simulation at every training step. So the robot is trying to solve the task with different light conditions, with different sizes of the objects, with different textures of the object. So you change it inside the simulator at every training step. So your simulated robot learns to capture all those differences. And by doing this, then it's more robust than when you transfer the controller into the real robot. Then you can apply directly to the real robot.
So basically, it's introducing noise.
Yes, it's kind of noise. It's kind of noise, yes, but it's very specific noise. It's not noise on the, let's say, it's not noise in the exact sense of the noise of a sensor that detects the distance. You know, the sensor, then it has some noise, maybe 1 millimeter noise. It's not that. It's that sometimes the object is going to be this size. Sometimes the object that you have to grasp is the half that size. Sometimes the object is going to have a light that is direct into it, or sometimes it's going to have the light from another angle. You know, so it's a step more on noise. It's a step more.
That is very interesting. That's definitely something I'm going to have to look into once I'm a step further, once the connection and everything works.
Okay.
So I think that's going to become important. It's one of the parts we haven't really figured out yet in the real simulation is how to introduce all the uncertainties to make the system more robust. So,
okay.
Thank you. Yeah, I'll definitely.
Yeah, that's a method. Actually, in our company at the Construct, we have built a complete project because so this method, domain randomization, was published on a paper some years ago. I think 2016 by the people of the OpenAI, and then we have replicated this paper into our system. So we have all the ROS packages, all the simulations, even the connection to the real robot. We have made a collaboration with Robotics for transferring into their Tiago robot. So if you are interested, I can send you the ROS jet. We have a thing that is called ROS jet, so we can share this code with you, and you can reproduce this on the cloud with the same conditions as we have designed this ROS jet, because it contains everything: the simulations, the code for training, the data sets. It contains everything, and then so you can be able to reproduce. Yeah. So let me send you the ROS jet later when we finish. Yeah. Yeah. Okay. And one other question is about your this specific robot. This how can we call this other robot? Not the Kinova one, but the other one?
Just call it the fabric gripper robot. Okay. Because the complex thing is grabbing fabric and deforming it without creating crinkles, without shearing the fibers in the wrong direction. Because with fiber composites, they're very strong in the direction of the fibers. But perpendicular to them, they're very weak. So how the fibers are being laid in the part has a major impact on the quality of the product. So the complex thing is gripping the fabric, deforming it, and placing it.
Okay. And then this robot works with ROS?
I'm not sure yet. The control is not probably properly implemented yet.
Okay.
But it can, or it could work with ROS.
I mean, it's a goal. It's a goal to have it. I mean, I'm asking you that because you are learning ROS, and then I was wondering if it's going to be worth your effort for testing.
You know, if our method works and it worked with ROS, then I don't see a reason why it wouldn't be implemented.
Yeah. Okay. Like,
in that case, you develop the same thing twice.
Yes, exactly. With another type of controllers. Yeah. With a framework for controlling the robot. Okay. Then in that case, so let me recommend you that you have to do the course of ROS control. That it's about.
Yes, I will do that next. Yeah.
Yes, so that you have to do that one next because you're going to need it when you change to the other robot. Okay, and then so if you are using Kinova robots, that I know them. What's the name of the specific robot of Kinova that you are using?
We are using the Jaco 2 with 6 degrees of freedom.
Okay, 6. And what about the gripper? So are you using a
3-finger?
A 3-finger. Okay.
No, it's for the simple robot.
Okay.
The complex robot, the DLR robot, consists of 127 suction units that can all be controlled individually and can deform on several axes. So you can see, there's a lot of variables. There's like way too much for a human to comprehend.
Yes, I think that you are right. The only solution is to make the robot learn by itself how to use it instead of programming.
Exactly.
Okay, and then if I understand, then you are learning ROS 1, not ROS 2.
Yes, ROS 1, yes.
ROS 1. Okay, and in which language of programming? So for ROS, you can do it with Python or C++. Which one?
Yes, I'm using Python. I learned at university a little bit of C++, but Python is just simpler. I think it's more intuitive. And the major reason is that the doctorate doing the machine learning and reinforcement learning, he's using Python with OpenAI. So
okay.
Just seemed natural.
Yes, but then there you have a problem because OpenAI works with Python 3.5 or 3.7. I don't remember, but it's 3. And then ROS is mainly working with Python 2.7.
Yes, but our goal is, because the reinforcement learning part is very CPU intensive, and the gazebo simulation as well. So our goal is to basically have two systems set up with ROS and communicating over the network. I already figured that out using OpenVPN. That took a while, but I managed to do it. And basically, then it doesn't matter, what Python version they use.
That is right, because you have the two separated systems and they just communicate through the topics and services and so on.
Yes, exactly.
Great.
That's the beauty of ROS.
Yes, exactly. That's super cool. Yes, very good. So then what was your level of ROS before you started to learn at the academy?
Okay, so at the academy, I'm almost done with the ROS basic in 5 days. And I would say most of this stuff I kind of knew before, but it took me way longer to learn those things. And there were definitely some things I learned that were kind of new, or just a better way of doing it and like properly understanding some of the aspects. So yeah, basically the ROS basic in 5 days, but not at the same quality level.
Okay, not the same
understanding.
Deep, let's say.
Yeah.
Okay. So then, what is it, by taking this course? Then you have make the better connections in your brain. So you have been able to relate,
like properly understanding how the service or actions work. Like before, I did the tutorials that are available on the internet, and I kind of understood it, but not to the same degree. How to implement it properly. So that was really good.
Okay, for me, so why we created the academy in this way is because for me, for my personal experience, I could read the tutorials and I can understand what they were explaining, but I didn't see the point. It's like, okay, so what? Like it's when they explain to you, well, what is the sinus? The sinus is the opposite side of the triangle divided by the hypotenuse. I don't know how to say in English. Yeah. So I can understand this concept. Okay, divided. So what? I mean, why should I pay attention to this?
Exactly. That was my biggest problem. Like, I started out completely not knowing anything about ROS. And the biggest problem was knowing what I have to know. Like, where do I start? And I did the basic ROS, the first steps on like the wiki, but it just didn't really connect everything that well. And it didn't create much understanding. So you did all those little examples, but you didn't really build your own project. You didn't connect all the things properly together. And yeah, what I've learned now, in basically 1 week, took me like 2 months before trying to do it on my own.
Wow.
So yeah, I'm really enjoying the academy so far.
Oh, thank you. Thank you. Can we quote this? 1 week while you take you 2 months? That's super cool. Good.
Yeah.
Okay. Just joking. Don't worry.
Yeah,
Okay.
you're welcome to do so. It's true.
Okay.
I wish I would have done that from the start. I would be much further ahead in my thesis now.
Oh, so thank you very much for saying this. This is, I'm going to say that to the team, and they are going to be very happy because every time. Go.
Yeah, another big thing is also when being new to Linux or somewhat new, and to the whole catkin process and ROS and everything. It just took me a long time to even just compile a project because I didn't know about all the dependencies, how the things work properly together. You have like error after error, and you have to troubleshoot why is this error popping up, just to get your operating system ready. Then there's like the different Linux versions that are compatible with different ROS versions that are compatible, maybe compatible or not with what Genova gives us. So getting everything to work, to just load up Gazebo with the model was very complex. And that's what's nice about the Academy. You set everything up. So you just load it up, and in the virtual environment, you can start learning. You don't have to go through that painstaking process of getting your system up and running, which can be very daunting and difficult if you're starting out with zero knowledge, basically.
Okay, yes, that's a very good point. This is also something that we took into consideration because many other methods for learning ROS, even the books. So when you buy a book that it's about teaching you ROS, the first thing that they do, all the methods, the first thing is how to install ROS into your computer and how to install Ubuntu and then what we thought is that, but I mean, these guys don't know anything about that. So we start with a very complex task before they can start learning.
Yeah.
So we decided to make it the other way around. So you start with everything already set up for you. And then the final chapter, I don't know, you have a write that it actually is an appendix. It says, okay, now that you know how to use ROS, how to program ROS, how to compile this and that, then if you want to install in your local computer, that's the way. And then I think that in your brain, it's more accommodated, the things.
Yes, definitely.
Oh, okay, that's very nice that you say that, because so it's going in the direction that we wanted to go. Very, very good. Okay, so let me see here. About the different courses that you are going, or ROS skills that you need to master. Which ones have you selected? So, I mean, which courses you would like to take, which subjects, specifics of ROS you would like to learn?
Well, first of all, just the whole basic thing, because even though I already know a bunch, I'm sure that there's more things that I don't even know that I should know. To have a very good foundation for everything I'm gonna do, and then using OpenAI ROS, so all the courses that deal with that and reinforcement learning.
Okay. Yeah, so the OpenAI ROS course that we have, that is very interesting. Are you attending to the ROSCon, by the way, this year?
No.
Okay, we are giving a workshop at the ROSCon about how to use OpenAI with ROS.
Where is that?
It's a little bit far. It's in Macau, in China. The ROSCon.
Okay. Yeah, I'm not sure my financial situation will allow that, and maybe the time. So
okay, maybe the university can pay for that because it's for purposes directly related to your PhD?
I can ask, but I can't promise anything.
Yeah. Okay. No, just letting you know, just in case, because it's going to be completely practical. So everybody is going to practice to make a robot learn with OpenAI.
Yeah, that sounds very cool. And the
so
OpenAI ROS is actually how I discovered you guys. Because I was searching for a way to connect OpenAI, which the reinforcement learning algorithms use, which the doctorate here uses, and Gazebo and ROS. And then I came about posts about OpenAI ROS, which you created. And I tried to implement the things on my own, but it's not that easy. And then after some time, I saw your academy, and then I just said, let's just give it a go. And I'm happy I did it.
Okay. That's a very interesting path for learning, and it's clarifying a lot. And then, here is a question that you have answered already, that about you using the simulated robots or the real robots. And you answered already that you are going to use both, actually. And you explain a very interesting concept that I don't know if most of the people at the audience will know. And that is the concept of digital twin. Can you explain us a little bit what is this concept about?
Yes. So that is exactly the term we're using. So you're using a digital twin to train a real robot. So if you run reinforcement learning, or machine learning, where the brain basically has to figure out how to do a task. If you do that with a real robot, you have to run your real robot. If that robot is used in production, you're losing a lot of money, because while you're training, it cannot produce other things. Another thing is, a robot, it can only run at its operating speeds and settings, while with a simulation you can speed it up. So if you have a powerful machine, you can do the same task much faster. So you create a simulation, a digital twin that's physically accurate, that takes the same inputs, that has physics enabled collisions, friction, everything, and you let your machine learning train on that. And basically it doesn't really know that it's a simulation. So basically it acts like the real thing. So it's a digital twin. And then you train your machine learning algorithm, reinforcement learning algorithm, on that digital twin. And once it learned a task, I don't know, pick this up and place it here, which might sound simple, but it's not really. Where the thing you have to pick up could be, in slightly different positions, different orientations, and all that. So it's not that simple. But once it learned that on the digital twin, then you basically know, or the machine learning knows how to control the real robot. And then you just load it to the real robot, and it can do the new task immediately.
Okay. So here I would like to say two things. The first one is that what you mentioned is exactly the basis of ROS. So in ROS, if you have a program that is running on ROS, the actual program doesn't know if it is connected to the simulated robot or the real robot. So it's going on your requirements. So very good selection. And then the other thing that I would like to say is that at present, the simulations, they are not so accurate for, call it like a digital twin of the real one. So how do we manage that?
Well, that is true. That is one of the challenges, of course. So at the start, we can't expect, once it's just called the brain, once the brain learned it on the digital twin, that it can immediately do it perfectly with the real robot. Okay. So you learn the task with a digital twin, and then load onto the real robots and try it there, and then it keeps learning and refining the model it learned with the real robot. But it's already close enough, because like at the start, just figuring out how to do it like at all, to like just a beginner level, takes a very, very long time. Once you have a somewhat working model, just fine-tuning it with a real robot is then much quicker. So you then still use your real robot. And depending how different it is from the digital twin to the real robot, you can then probably adjust your environment of the digital twin to better represent the real robot.
Okay, yeah, then I think that we can say that the digital twin concept includes the simulation concept plus lifelong learning of the model of the simulation itself based on the results that you get into the real robot.
Exactly.
It's not a static simulation, but it refines based on the results of the real one.
Yeah.
Okay.
I mean, everything with machine learning, there's nothing static about it.
Yeah.
It's about doing things over and over and over again, and like trying to get better every time. That's the thing where robots are so much better than humans, because there's so many variables and so much data a human just can't comprehend it. And like even when the machine learning manages to do something, we often don't really know why it works or what exactly it figured out, what the best variables are, but computers are good at that.
Yes, that's one of the criticisms that many people says to the machine learning current algorithms, because we cannot see the reason why it's doing it so well.
Yeah, there's a lot of research being done trying to open that black box. So black box refers to a term when you see the start, you see the end, but you don't really know what's happening in between. And I attended a conference 2 weeks ago which dealt with that. There were some excellent speakers, and they're trying to develop new methods that allow us to look into, see and understand really what is being done. But at the moment it is very difficult.
Yes, it's very difficult with those massive neural networks that we are using. So it's very, very difficult. Okay, let's see how this field goes in the future. And then another thing, it's about the, let me see here in my questions. So you mentioned that you are more into the aerospace engineering field than in the robotics field. So you are applying robotics to that field, but you are more into the actually aerospace engineering field. So based on your experience in both fields, in the robotics and the aerospace engineering, why do you think that learning ROS could be interesting for those engineers at the aerospace industry?
Okay, so as I said, I'm studying aerospace engineering, and my focus is on aircraft propulsion and space propulsion. And while ROS will probably not be used, in an airplane or in a satellite or rocket, there's so many components that have to be manufactured. And then I think a big application of ROS can be the manufacturing, because there are going to be more and more robotics. So far, robots are being used for very simple, repetitive tasks that require a lot of precision. So, welding, like a lot of metal work is being done with robots, with CNC control. But a lot of things, especially, with fiber composites, maybe cable rounding, there's so much things, a simple task of just stripping 2 wires or 2 plugs and connecting them. For human, that's simple. For robots, almost impossible nowadays.
That's right.
So with machine learning and robotics, I see a huge future in AI in all engineering fields. And I think a lot of engineering fields will change drastically or even die off. And that's why I want to be there from the start. And I see ROS as just a very good implementation or way of learning it. There's other systems, but they're usually, by a company. They're not open source. And once you know how it works and like one of the systems, you can implement it easily. So the future or the application I see for aerospace engineering is more in the manufacturing side, but there will definitely play a huge part, and especially if ROS and OpenAI and machine learning, if that becomes like a very solid package together, I see a huge potential future there.
Yeah, something like in the future where we can actually plug a component that is actually learning, and then you just show and then it learns in a more automatic way. So actually we don't have to build those learning packages or in order to create the digital twins maybe in the future. I think that Microsoft is going on this direction, on trying to provide us with those automatic learners that you can plug and then it learns.
I mean, there's so much happening in the field, so it's hard to predict where things are going, like concretely. But I mean, you have to, like, I want to do something. I want to be part of it, and this just seems a good way to do so.
Okay. Yes. Well, I can feel that you are going to have a bright future on that. Yeah, I can feel it. Yeah. Then let's finish here. But before we finish, I would like to ask you for a last question. So, who would you recommend to? Which kind of person to recommend to study ROS at our academy instead of learning using all this information scattered around the internet?
I think anybody who actually wants or has to learn ROS and use it. I mean, if you're just, want to play a little bit, tinker around, maybe you don't have to do it. But if you're like me and you need it for your thesis or for your studies, like you actually want to learn it, definitely go with the academy. As I said, what took me like 2 months to figure out, I basically learned in a week here. Just so much less headache. And so much simpler. And yes, it costs a bit of money, but time is also money. And 2 months of work instead of 7 days, that seems like a good deal to me. So anybody who really wants to learn ROS, especially from scratch, from a zero level, I would totally recommend.
Okay, then let me ask you also something, because then it sounds like we are very, very good and perfect. So we are very good but not perfect. Then something else that maybe you would like us to improve, that you would like us to, this thing, I think that you can do it better, or you can change it this way. Any recommendation on this side?
So far, I'm very happy. I mean, of course, the performance could be slightly better, especially with the graphical tools. They're very slow. But, I mean, I understand that creating all the virtual machines takes a lot of hardware and setup. But it's very usable. It could be a bit faster.
Okay.
But so far I'm very happy with it.
Okay, great. So this is one of the important points that we are attacking in our academy now, to move faster, because I also feel like that it should be faster, the whole system. So the whole opening of the notebooks and the simulations here and your execution of your code. So I think it's very fair, the recommendation. Okay, so that is all. Thanks a lot, Simon, for being here.
You're welcome. Thanks for having me.
Okay, see you around the world then. Maybe at the ROSCON
I
or
will see
somewhere
you.
else. Okay.
Sure, we'll meet again in the future.
Yeah.
Have a good one.
And for all the listeners, let me remind you that if you want to become a roboticist or an AI researcher applying robotics, then you need to learn ROS, because ROS is the standard in robotics. How can I learn ROS fast? How can I do it? Very simple, as Simon was explaining here. Have a look at the Robot Ignite Academy. We have created the 30-70 teaching method, which is based on 30% of the time learning the theory and 70% of the time practicing with simulated robots. We provide a complete path for beginners, starting by teaching you about Linux for robotics and Python for robotics. And then we continue with the basics of ROS, and then at the end you can build your own ROS robot, real ROS robot, step by step. Have a look at www.robotignite.academy. And that is all for today. Thank you very much, everyone there, all the ROS developers, and see you next week with a new lesson from the expert. Until then, keep pushing your ROS learning.
Developers, podcast.